June 4, 1944. Southwick House, Portsmouth, England. The rain hammers against the windows of the Manor's library, now converted into the nerve center for the largest amphibious invasion in history. Supreme Commander Dwight D. Eisenhower stands before a wall-sized map of the Normandy coast, his jaw tight as he listens to Group Captain James Stagg deliver the weather forecast for the third time in as many hours. The meteorologist's voice is steady, but his words are damning. Low cloud, high winds, rough seas through June 5th. Around the table, the men who will command Operation Overlord sit in uncomfortable silence. General Bernard Montgomery fidgets with his reading glasses. Admiral Bertram Ramsay studies his hands. Outside, 156,000 men wait in marshalling areas and aboard 5,000 ships, eating cold rations and writing letters home they hope won't become their last words. But the weather is only part of Eisenhower's problem tonight. The real nightmare has been keeping him awake for months, and it has nothing to do with German beach defenses or Rommel's panzer divisions waiting inland. It's simpler and more fundamental than that. How do you get a 30-ton Sherman tank across 200 yards of open water and onto a beach without it sinking like a stone? The answer should be impossible. Tanks don't float. Steel and water have never been friends. Yet in the equipment parks scattered across southern England, hundreds of Sherman tanks sit wrapped in what looks like canvas bathtubs, fitted with inflatable screens that rise up around their hulls like fabric skirts. The official designation is DD tank, Duplex Drive. The soldiers call them Donald Ducks. Some call them floating coffins. The whole contraption is the brainchild of one man, and depending on how the next 48 hours unfold, Nicholas Straussler will either be remembered as a genius or the engineer who sent hundreds of tankers to the bottom of the English Channel. Straussler isn't at Southwick House tonight. He's not the type for command conferences or medal ceremonies. At 49 years old, the Hungarian-born engineer prefers the company of blueprints and prototypes to generals and politicians. Right now, he's probably somewhere in a workshop, tinkering with another impossible idea, utterly unaware that his reputation hangs in the balance of a weather front moving across the Atlantic. The path that led to this moment began 3 years ago, long before anyone was planning the invasion of France, when the problem of amphibious armor was just a theoretical exercise buried in some staff officer's filing cabinet. Britain in 1941 was not thinking about invasion, it was thinking about survival. The evacuation at Dunkirk had stripped the British Army of nearly all of its heavy equipment. Hundreds of tanks sat at the bottom of the Channel or abandoned on French beaches. The island was practically defenseless, and across that narrow strip of water, Hitler's Wehrmacht was preparing Operation Sea Lion, the invasion of Britain. That's when the War Office started asking uncomfortable questions. If the Germans came, how would they land their panzers? And more importantly, how could Britain stop them? Or better yet, how could Britain do the same thing in reverse when the time came to return to Europe? The Royal Engineers had been experimenting with amphibious vehicles since the 1920s, but everything they'd tried was either too slow, too vulnerable, or too specialized to be useful in a real assault. You could build a tank that floated, but it wouldn't have enough armor to survive on a beach. You could build a landing craft to carry tanks, but getting them ashore under fire was suicide. The landing craft would have to beach itself, drop its ramp, and wait while 30 tons of steel rolled off into the surf, assuming the surf wasn't too deep and assuming German machine gunners weren't turning the ramp into a shooting gallery. What they needed was a regular tank, fully armed, fully armored, that could swim ashore under its own power, ahead of the infantry, ready to fight the moment it touched sand. Nicholas Straussler had been thinking about this problem longer than most. Born in Hungary in 1897, he'd studied engineering in Vienna before the First World War interrupted his education and put him in an Austro-Hungarian uniform. After the war, he bounced around Europe, working on automotive designs, obsessed with the mechanics of mobility. By the 1930s, he'd settled in Britain and established himself as a designer of military vehicles, including a four-wheel drive system that would later become standard on British armor. But his real passion was amphibious vehicles. While other engineers saw water as an obstacle, Straussler saw it as just another terrain problem. In 1940, he designed a strange little vehicle called the folding boat, a collapsible reconnaissance car that could cross rivers. The War Office had been mildly interested, but not impressed. Too fragile, too limited. Then came the fall of 1941, and a meeting that would change everything. The man sitting across from Straussler in the War Office conference room looks skeptical, and he has every right to be. Major General Percy Hobart is not easily impressed. At 56, he's already earned a reputation as one of Britain's most innovative and most difficult armor commanders. He'd been forced into retirement in 1940 after clashing with superiors over tank doctrine, only to be recalled by Churchill himself when Britain realized it needed every experienced tank officer it could find. Hobart commands the 79th Armored Division, a unit that exists specifically to solve impossible problems. His engineers are developing tanks that clear minefields, tanks that lay bridges, tanks that shoot enormous mortars. The military establishment calls them Hobart's Funnies, a nickname that sounds dismissive until you see what these machines can do. Now Hobart needs a tank that swims, and he's heard Straussler might have an answer. Straussler spreads his drawings across the table. What he's proposing sounds insane. Take a standard Sherman tank, attach a collapsible screen made of rubberized canvas around the hull, inflate it with compressed air, and drive the whole thing into the sea. 2 propellers mounted at the rear, driven by the tank's engine through a power takeoff, would push it through the water at about 4 knots. Once it reached the beach, the crew would collapse the screen and the tank would fight normally. Hobart studies the drawings in silence. The concept violates everything he knows about armored warfare. Tanks are supposed to be heavy, protected, intimidating. This looks like a Sherman wearing a paddling pool. "How much does the screen weigh?" asked Straussler. "Less than a ton," he replies. "The struts are tubular steel, the canvas is waterproofed fabric reinforced. The inflation takes about 15 seconds. And if it tears, the tank sinks." Hobart appreciates the honesty. He asks about stability, about waves, about what happens when a shell lands nearby. Straussler has answers for most of the questions, theories for the rest. The truth is, nobody really knows if this will work in combat conditions, because nothing like it has ever been tried. But Hobart sees something in the design that others might miss. It's not elegant, but it's practical. It uses existing tanks, existing engines, existing crews. You don't need to build a whole new vehicle. You just need to teach a Sherman to swim. "Build me a prototype," Hobart says. "I'll get you a tank." 3 months later, in early 1942, the first DD tank rolls into a testing facility at Henley-on-Thames. The location is chosen for secrecy and practicality. Quiet countryside, access to water, far from prying eyes. The initial trials are conducted on calm rivers and lakes, conditions that bear little resemblance to the English Channel. The first time they lower the prototype into water, half the engineering team expects it to sink immediately. The canvas screen rises up around the Sherman's hull, held rigid by 36 pneumatic struts, forming a boat-like shape that extends 3 feet above the tank's normal height. The whole thing looks ridiculous, like a child's bath toy scaled up to industrial size. Then the driver engages the propellers, and the tank begins to move. It works. Barely. The Sherman wallows through the water like a drunken whale, slow and ungainly, sitting so low that waves slosh over the top of the screen. The crew inside can see nothing but canvas and sky. They navigate by periscope and compass, trusting instruments and prayers in equal measure. But it floats, and it moves. And when it reaches the beach, the driver pulls a release lever, the screen collapses in seconds, and suddenly it's a tank again. Turret traversing, gun ready, tracks biting into mud. The trials continue through spring and summer. They test different water conditions, different sea states, different approach angles. They discover problems. The screen is fragile, vulnerable to anything sharp. The propellers are underpowered in currents. If the tank tilts more than a few degrees, water pours over the screen and the whole thing goes under. But they also discover that with training, crews can handle these machines. They learn to read the water, to angle their approach, to feel the weight distribution through the controls. It becomes less about engineering and more about seamanship, turning tankers into sailors, whether they like it or not. By late 1942, Hobart is convinced enough to order production. The DD tank is approved for the 79th Armored Division, and training begins in earnest. Crews practice at Gosport, launching from landing craft into Portsmouth Harbor, swimming toward designated beaches while instructors time them and critique their performance. The soldiers hate it at first. Tankers are used to feeling protected, surrounded by armor. Inside a DD tank on the water, they're sitting in what amounts to a steel bathtub wrapped in canvas, riding lower than the waves, blind to everything except the small circle of sky visible through the commander's periscope. If something goes wrong, if the screen tears, if a wave hits wrong, if the engine stalls, they have maybe 30 seconds to get out before the tank drags them to the bottom. Some crews refuse to train in them. Others complete the course and request transfers. But enough stay, and gradually, reluctantly, they begin to trust Straussler's design. By early 1943, the DD tank is no longer experimental, it's operational, and planning for the invasion of Europe is beginning to accelerate. The strategic debates happen at levels far above Straussler's pay grade. Churchill and Roosevelt meet in Casablanca and commit to opening a second front. General Frederick Morgan begins preliminary planning for a cross-channel invasion under the codename Operation Overland. By summer, Eisenhower arrives in London to take command, and the planning shifts from theoretical to urgent. The invasion plan is staggering in its complexity. 5 beaches across 50 miles of Norman coastline, airborne drops behind the lines, naval bombardment, aerial bombing, and 156,000 men hitting the shore in the first wave that have been fortified for 4 years. The meeting takes place in March 1944, in a nondescript building in London where the invasion's operational details are being hammered out. Around the table sit the men responsible for turning Overlord from a plan into reality. Eisenhower, Montgomery, Bradley, and a dozen other senior officers whose names will appear in history books. The topic is fire support on the beaches, specifically how to get it there in the critical first minutes when infantry are most vulnerable. The traditional approach is simple. Naval gunfire and airstrikes soften the defenses, landing craft deliver the infantry, then follow-up waves bring tanks ashore once the beach is secured. But secured is a relative term when you're facing German pillboxes, machine gun nests, and artillery positions with clear fields of fire across open sand. Montgomery advocates for a different approach. Put the tanks in the first wave. Let them swim ashore ahead of the infantry or alongside them so that when end soldiers hit the beach, they have immediate armored support. The DD tanks make this possible. The American commanders are less enthusiastic. General Omar Bradley has seen the DD tanks during demonstrations, watched them wallow through calm water in controlled conditions, and he's not convinced they'll survive in the real thing. The English Channel on a June morning is not a placid lake. It's cold, rough, unpredictable. Waves that look manageable from shore can swamp a low-riding vehicle in seconds. Bradley does the math in his head. Each DD tank carries a crew of 5. If the invasion fleet launches them too far from shore in seas too rough for the canvas screens to handle, hundreds of men could drown before they ever see the beach. And for what? To deliver tanks that might arrive 10 minutes earlier than landing craft could bring them? The debate goes back and forth. Montgomery argues that the risk is worth it, that tanks arriving with the first wave could mean the difference between success and slaughter. Bradley counters that dead tankers at the bottom of the channel won't help anyone. Eisenhower listens to both sides, then makes the call that will affect thousands of lives. The DD tanks will be used on D-Day, but each beach commander will have discretion on launch distance. If conditions are too rough, the landing craft can take them closer or deliver them directly to shore. It's a compromise that satisfies no one and leaves the final decision to men who won't know if they're making the right choice until it's too late to change it. Through April and May, the training intensifies. At Studland Bay in Dorset, crews practice full-scale assault landings, launching from landing craft 2 miles offshore and swimming toward the beach while live ammunition cracks overhead. Some tanks make it. Others swamp and have to be recovered by support vessels. A few sink, and divers spend hours searching murky water for crew members who didn't get out in time. The accidents are classified, kept quiet to maintain morale, but word spreads anyway. Soldiers know the risks. They know that on D-Day, there won't be support vessels hovering nearby, ready to fish them out if something goes wrong. Nicholas Straussler visits the training sites occasionally, watching his invention put through trials he never imagined during those early tests on the Thames. He makes modifications based on feedback from crews, reinforcing stress points on the screen, adjusting the propeller mounts, improving the quick release mechanism. But there's only so much he can do. The fundamental design is locked in. Thousands of canvas screens are already manufactured, shipped, and being fitted to tanks across southern England. By late May, the invasion force is assembled. In marshalling areas from Cornwall to Kent, soldiers and equipment wait under camouflage netting. The DD tanks are particularly difficult to hide. Their distinctive screens mark them as special even when collapsed. Security teams confiscate cameras and restrict movement. Everyone knows something big is coming. No one knows exactly when. The date is set for June 5th, then postponed 24 hours due to weather. That brings us back to Eisenhower in the library at Southwick House, listening to rain against the windows and weighing a decision that affects millions. At 4:15 a.m. on June 5th, after consulting with his meteorologists one final time, Eisenhower gives the order. Okay, we'll go. The machine lurches into motion. Ships begin loading, aircraft are fueled and armed, paratroopers check their chutes, and in equipment parks across southern England, DD tank crews start their engines and begin the process of waterproofing their vehicles for the swim ahead. The tanks being prepared for Normandy aren't perfect. Everyone knows this. The canvas screens are vulnerable to anything sharp, shrapnel, debris, or even aggressive handling during loading. The propellers are underpowered for any kind of serious current. The crews have maybe 90 seconds to escape if the tank goes under, and that's assuming they're not disoriented, not tangled in equipment, not frozen by cold water or fear. But the alternative is worse. Without armor in the first wave, the infantry will be slaughtered on the beaches. The Germans have been fortifying Normandy for years, building obstacles and strong points designed specifically to stop an invasion at the waterline. Rommel himself has overseen the defenses, and he's made it clear what he expects. Throw the Allies back into the sea or die trying. The DD tanks represent a calculated gamble that armor can reach the beach at the moment it's needed most, providing covering fire while infantry find their footing and push inland. If it works, it could save thousands of lives. If it fails, the failure will be spectacular and very public. Late on June 5th, the invasion fleet begins to move. From ports and harbors across southern England, ships slip their moorings and head south toward assembly points in the Channel. The flotilla is enormous. Battleships, cruisers, destroyers, minesweepers, in more than 4,000 landing craft of various types, carrying everything from infantry to artillery to the precious, fragile DD tanks. The sea is rough, but not impossible. Waves run 4 to 6 feet, higher than anyone would prefer, but within operational limits. The meteorologists promise conditions will improve as they approach the French coast. Inside the landing craft, DD tank crews try to sleep, or write letters, or just sit with their thoughts. Some pray, some joke to cover their nerves. All of them know that in a few hours, they'll be doing something no tankers have ever done in combat, driving their vehicles into the ocean and hoping Straussler's canvas screens hold long enough to reach the beach. The convoy moves through darkness, an armada so vast that ships stretch across the horizon in every direction. Aboard LCT 535, landing craft tank, Sergeant Bill Anderson of the 741st Tank Battalion stands on deck watching the coast of England disappear into the gloom. Around him, 4 Sherman DD tanks sit chained to the deck, their canvas screens folded down, looking almost normal except for the twin propellers jutting from their rear mounts. Anderson commands the 2nd tank. He's 24 years old, from Ohio, trained on Shermans at Fort Knox before shipping to England 8 months ago. The DD qualification course at Studland Bay was the strangest 2 weeks of his military career, learning to navigate by compass while sitting in a steel box barely above water, practicing emergency escapes until he could find the hatches blindfolded, memorizing the exact sequence of lever pulls that would collapse the screen and return his tank to something resembling normal. His crew is below deck, trying to stay warm. Driver George Hayes, gunner Tommy Chen, loader Richard Murphy, and radio operator Jack Foster. They've trained together, fought together in exercises, and now they'll swim together into combat, or sink together trying. The channel crossing takes hours. The LCT rocks and pitches in the swells, and more than a few men lose their dinners over the side. Anderson stays topside, despite the cold, preferring fresh air to the diesel-soaked compartments below. Other tank commanders do the same, a silent brotherhood of men trying not to think too hard about what comes next.
Around 2 a.m., the fleet reaches the transport zone, a designated zone about 12 miles off the Norman coast where the larger ships will anchor and smaller craft will make the final run to shore. The night is split by the roar of bombers overhead, thousands of aircraft heading toward France to hammer the coastal defenses. The naval bombardment hasn't started yet. That will come closer to dawn. At 3:30 a.m., the landing craft carrying the DD tanks move forward from the transport zone, heading toward their designated launch points. The original plan called for launching the tanks 5,000 yards offshore, nearly 3 miles, giving them time to form up and swim toward the beach in organized waves. But the sea conditions make that plan look suicidal. Even in the pre-dawn darkness, Anderson can see waves breaking white across the water, higher and meaner than anything they faced in training. The LCT skipper, a Navy lieutenant who looks about 19, keeps checking his watch and his charts, trying to decide what to do. Utah Beach gets lucky. The commanders there, seeing the rough conditions, make the call early, take the tanks to within 1,000 yards of shore before launching, close enough that the swim is manageable, far enough that the landing craft aren't sitting targets for German artillery. Omaha is a different story. Omaha is the nightmare scenario planners have feared all along. 4 miles of beach backed by high bluffs with limited exit routes and German positions that command the entire shoreline. The aerial bombing meant to crater these positions largely misses. The naval bombardment, when it starts at 5:50 a.m., is impressive but ineffective, most shells falling short or overshooting the fortified strongpoints. At 5:30 a.m., as dawn breaks gray and cold over the channel, the decision is made to launch the DD tanks of the 741st and 743rd Tank Battalions at their planned distance, 6,000 yards from shore. Anderson's LCT reaches the launch point at 5:45 a.m. The ramp drops and cold spray immediately soaks everyone on deck. The first Sherman, commanded by Lieutenant Davis, rolls forward to the edge. The crew has already erected the canvas screen, inflated it with the compressed air cylinders. The screen rises up around the tank like a fabric wall, held rigid by the pneumatic struts, and making the Sherman look twice its normal height and utterly absurd. Davis gives the signal. The Sherman rolls off the ramp and drops into the sea with a massive splash. For a moment, it seems to hesitate, wallowing in the wake of the LCT, water sloshing over the top of the screen. Then the propellers engage and the tank begins to move, painfully slow, rising and falling with the swells. Anderson's tank is next. His crew scrambles up from below deck, faces pale in the dawn light. Hayes takes the driver position, Foster mans the radio, Chen and Murphy squeeze into the turret beside Anderson. The screen is already up, struts locked, everything secured. "Ready?" Anderson asks over the intercom. The responses come back clipped and tense. Nobody's ready for this, but they're doing it anyway. The LCT skipper counts them down. 3, 2, 1, go. Hayes hits the throttle and the Sherman lurches forward off the ramp. The impact with the water is violent, a bone-jarring crash followed by immediate darkness as the tank submerges. For 3 terrifying seconds, Anderson feels the Sherman sinking, water pressure building against the canvas, and he's reaching for the escape hatch when suddenly we're rising, buoyant, the canvas holding. Through his periscope, Anderson sees nothing but gray sky and green water. The canvas blocks his view in every direction except straight up. He has a compass mounted beside him, a bearing scribbled on his wrist with grease pencil, and a watch that says 5:47 a.m. The beach is 6,000 yards south. At 4 knots, that's about 30 minutes of swimming. 30 minutes blind, riding waves that could swamp them at any moment, hoping the screen holds and the propellers keep turning and nothing goes catastrophically wrong. Behind them, the rest of the company launches. 29 DD tanks from the 741st Battalion drop into the channel and begin the swim toward Omaha Beach. Within 10 minutes, 27 of them have sunk. Anderson doesn't know this yet. He can't see anything but water and sky. The radio is alive with chatter, other tank commanders reporting their positions, calling out compass bearings, trying to maintain formation in conditions that make formation meaningless. The Sherman pitches and rolls with each wave, climbing swells that feel impossibly steep, sliding into troughs where water pours over the screen in sheets. Hayes fights the controls, trying to keep them pointed south, but the current is pushing them east and the propellers barely have enough power to make headway. Inside the turret, Chen and Murphy brace themselves against equipment, staying quiet because there's nothing useful they can say. Then Foster's voice crackles over the intercom. "Sergeant, Lieutenant Davis is gone. His radio just cut out." Anderson's stomach drops. A radio cutting out could mean anything. Equipment failure, antenna damage, crew too busy to talk, or it could mean what he suspects. The tank has sunk and Davis and his crew are either fighting their way out or already drowning.
The next call comes 2 minutes later. Sergeant Henderson's tank, third in line during the launch, reports they're taking on water. The canvas screen has torn, maybe hit debris from another sinking tank, maybe just weakened by the constant battering of waves. Henderson's voice stays professional even as his tank begins to list. We're going down. Evacuating now. Anderson hears the transmission cut off mid-sentence. He doesn't hear anything after that. The sea is claiming them one by one. Tanks that looked seaworthy in calm harbors become death traps in 6-foot swells. Water pours over screens with each wave. Canvas tears on debris floating just beneath the surface. Pieces of landing craft, sections of obstacles jettisoned from other vessels, wooden planks from God knows where. Some screens simply collapse under the pressure, struts buckling, and suddenly 30 tons of steel is pulling 5 men toward the bottom. The crews who escape do so by training and instinct. They have seconds to pop hatches, fight their way out of turrets, kick free of equipment. The water is 58 degrees. Cold enough to sap strength in minutes, cold enough to kill in an hour, even if you're a strong swimmer. Mae West life jackets keep them afloat, but there's no time for rescue operations. The landing craft have already turned back toward the transport ships to load more troops. The destroyers and cruisers are focused on the beach ahead, guns hammering the bluffs. Men in the water can only watch their tanks disappear beneath the surface and hope they can tread water long enough for someone to notice them. Anderson's Sherman keeps swimming. Hayes has the controls locked in a death grip, constantly adjusting for the current, feeling the tank respond sluggishly to each input. The propellers are screaming at full power, barely pushing them forward against waves that seem determined to drive them backwards. Through gaps in the canvas when they crest a swell, Anderson catches glimpses of the beach, still impossibly far away, a dark line across gray water. Above it, he can see smoke rising from the bluffs where naval shells are impacting. Closer, he spots other DD tanks, canvas screens rising and falling with the swells. He counts 4, maybe 5, not nearly enough. The original plan called for 29 tanks from the 741st to hit Omaha Beach in the first wave, providing covering fire for the 116th Infantry Regiment. Without them, those soldiers will be running into German machine guns with nothing but rifles and determination. At 6:05 a.m., Anderson's tank is still afloat, still making progress, but barely. They've covered maybe half the distance. The beach is 3,000 yards ahead, and every one of those yards feels like it might be the one where their luck runs out. Then Foster speaks up again. "Sergeant, I'm picking up traffic from the 743rd. They aborted the swim. Their skipper took them in close and unloaded at the waterline." The 743rd Tank Battalion had been assigned to the other sector of Omaha Beach. Their landing craft commanders, seeing the same REF-Cs that are killing the 741st, made a different call. Ignore the plan, drive the LCTs right up to the beach, and drop the tanks in shallow water where they can wade ashore. It's the smart decision. It's also too late for Anderson and the handful of tanks still swimming. At 6:12 a.m., with the beach 2,000 yards ahead, Anderson hears the sound he's been dreading. A sharp crack followed by air hissing. One of the pneumatic struts holding up the screen has failed. The canvas on the left side sags inward, and immediately water starts pouring through the gap. "We're taking water," Murphy shouts from the loader's position, where water is already sloshing around his boots. Hayes tries to compensate, adjusting their angle to keep the damaged section as high as possible, but it's like trying to level a sinking ship. The Sherman lists the port, more water pours in, and suddenly they're riding lower, waves breaking over the screen from both sides. Anderson makes the calculation in his head. They're 2,000 yards out, 15 minutes of swimming if nothing else goes wrong, but things are already going wrong and getting worse by the second. The water inside the tank is rising, the propellers are struggling. Another strut failure, and they'll go down like a stone. He has 2 choices: keep swimming and hope they make it, or collapse the screen now and try to drive along the bottom toward shore, assuming the water isn't too deep, assuming the engine doesn't flood, assuming they don't get stuck in a crater or a sandbar. Both options are terrible. He picks the one that might keep his crew alive. "Drop the screen," Anderson orders. "We're going under." Hayes pulls the release lever, the canvas screen collapses in sections, pneumatic struts folding down, and suddenly they're not a boat anymore. They're a tank sitting in the middle of the English Channel with water pouring in through every gap and opening. The Sherman goes under fast. Water floods the turret, shockingly cold, and Anderson gasps despite himself. The tank hits bottom with a jarring impact, and for a moment, everything is chaos. Darkness, cold, the awful sensation of being trapped underwater in a steel coffin. But the water isn't as deep as he feared. Maybe 12 feet? The Sherman's hull is 10 feet tall, which means they're completely submerged, but not impossibly so. Hayes has kept the engine running through the waterproofing, rubber seals on every opening, an extended air intake and exhaust that rises above the water level. The engine coughs, sputters, then roars back to life. The tracks bite into sand and rock, and incredibly, impossibly, the Sherman starts moving forward along the seafloor. They drive blind, navigating by compass and prayer, water surrounding them on all sides. Anderson keeps the hatch sealed because opening it would flood them completely. They have air for maybe 10 minutes if the seals hold, less if they don't. The distance to shore is impossible to judge. Time stretches and compresses. Hayes just keeps the throttle open, driving toward what he hopes is the beach, while the rest of the crew sits in their positions doing nothing, because there's nothing to do except wait and hope.
At 6:19 a.m., the Sherman's nose tilts upward. They're climbing. The water pressure around them decreases. And then, suddenly, they break the surface. Turret first, then hull, water streaming off the armor in torrents. They've made it. They're on the beach, or at least the surf zone, waves still breaking around them, but it's shallow enough that they're functional again. No longer swimming, just a tank doing what tanks are supposed to do. Anderson pops the hatch, and immediately wishes he hadn't. The beach is hell. The sound hits Anderson first. A roar of gunfire so dense it sounds like fabric tearing, punctuated by the crump of mortars and the scream of artillery shells. Smoke drifts across Omaha Beach in thick banks, mixing with spray from the surf. Through gaps in the haze, he sees what the planners never showed them in briefings. Bodies in the water, men crawling across sand, soldiers huddled behind the few pieces of cover available while machine gun fire kicks up geysers of sand and blood. The beach is 300 yards wide from waterline to the seawall, and every inch of it is covered by German fire. The bluffs rising behind the beach are honeycombed with bunkers and fighting positions, concrete fortifications that shrugged off the naval bombardment like it was hail. From these positions, German gunners have perfect fields of fire across the entire landing zone. The first wave of infantry hit the beach at 6:30 a.m., right on schedule. Most of them never made it past the waterline. Landing craft dropped their ramps into storms of machine gun fire. Men loaded down with 60 pounds of equipment tried to wade through chest-deep water while bullets churned the surf around them. Some drowned, others were cut down before they reached the sand. The survivors crawled toward any cover they could find. A concrete obstacle, a destroyed vehicle, the bodies of their dead comrades. Without armor, they're pinned. Without the DD tanks that were supposed to arrive alongside them, they have no way to suppress the German positions. Anderson's Sherman is one of 5 DD tanks from the 741st Battalion that made it to shore. 5 out of 29. The rest are at the bottom of the channel, along with most of their crews. The 743rd Battalion, which landed their tanks directly from landing craft, got 8 tanks onto the beach before German anti-tank guns started finding the range. 13 tanks total on a beach that was supposed to have nearly 60 in the first wave. Hayes has the Sherman moving forward, tracks churning through wet sand, heading toward the seawall where infantry are clustered in desperate groups. Anderson traverses the turret, looking for targets through the smoke. Chen already has a high explosive round loaded. They're configured for infantry support, not tank combat, which is fine because there are no German tanks here, just bunkers and machine gun nests that need to be destroyed before everyone on this beach dies. Anderson spots a concrete bunker at the base of the bluffs, maybe 200 yards ahead. The bunker's firing slit is spitting machine gun fire in long bursts, sweeping the beach methodically. As Anderson watches, a group of soldiers tries to advance and gets cut down in seconds. "Gunner, bunker, 11 o'clock, 200 yards, Anderson calls over the intercom. Chen adjusts, peering through his sight. Identified. Fire when ready. The Sherman 75mm gun roars. The recoil rocks the tank backward. The shell impacts just to the left of the bunker's firing slit, blowing a chunk out of the concrete but not penetrating. The machine gun keeps firing. Load HE, Anderson orders.
Murphy already has the next round ready. The breech clangs shut. Chen makes a minute adjustment, accounting for the slight error in the first shot. Up, Murphy calls. Fire. The second shell hits dead center. The explosion inside the bunker is visible through the firing slit. A flash of orange flame, and then the machine gun goes silent. It's one position out of dozens. But it's something. It's a start. The other tanks that made it ashore are doing the same thing, spreading out across the beach, engaging targets wherever they can find them. Each bunker destroyed, each machine gun nest silenced, opens a small corridor where infantry can advance. It's not the overwhelming armored support the planners envisioned, but it's better than nothing. Anderson's Sherman keeps moving, firing, reloading. They knock out another bunker, suppress a mortar position, rake a section of trench with machine gun fire. The German defenders focus their attention on tanks because tanks are the most dangerous thing on the beach right now. Anti-tank rounds start coming back. High-velocity shells from 88mm guns positioned on the bluffs. An 88 round screams past Anderson's turret, missing by inches. Another hits the sand 10 feet away, showering them with debris. Hayes keeps the tank moving, zigzagging as much as possible on the crowded beach, trying not to run over wounded soldiers while making the Sherman a harder target. At 7:15 a.m., a shell hits the Sherman to Anderson's left, one of the other DD tanks that made it ashore. The round penetrates the thinner side armor, and the tank brews up instantly, ammunition cooking off in series of secondary explosions. Anderson doesn't see anyone get out. 12 tanks left. The battle grinds on through the morning. More landing craft arrive, bringing more troops, more equipment, more chaos. Engineers work under fire to clear obstacles and open exits from the beach. Navy destroyers move dangerously close to shore, risking grounding themselves to provide direct fire support against the German positions. Slowly, painfully, the American forces establish footholds at the base of the bluffs. By 9 a.m., small groups of infantry have made it to the top of the bluffs in a few places, finding gaps in the German defenses and exploiting them with grenades and bayonets. By noon, the German defenders are falling back from their forward positions, and the beach, while still dangerous, is no longer a killing ground. Anderson's Sherman is still fighting, though they're down to their last dozen rounds of main gun ammunition. The tank is battered, the canvas screen destroyed, one track damaged, the radio antenna shot away. But the engine runs and the gun fires, and that's all that matters.
At 2:30 p.m., they receive orders to pull back to a rally point and rearm. Hayes turns the Sherman toward the designated area, and for the first time since they hit the beach, Anderson allows himself to think about what they've just survived. They launched with 29 tanks. 5 made it to shore from his battalion. He has no idea how many of the crews who went into the water are still alive. He doesn't want to count yet. There will be time later to learn who made it and who didn't, to write letters to families and attend memorial services for empty coffins. Right now, he just needs to keep his tank running and his crew alive for whatever comes next. The full scope of what happened on D-Day doesn't become clear for days. The after-action reports trickle in slowly, filtered through exhaustion and trauma, assembled by staff officers trying to make sense of an operation that succeeded despite catastrophic failures. Of the 29 DD tanks from the 741st Tank Battalion launched 6,000 yards from Omaha Beach, only 2 made it ashore under their own power. 3 more arrived after their crews performed emergency procedures similar to Anderson's, collapsing the screens and driving along the seafloor. The rest sank. 27 tanks lost, along with most of their crews. Some men were picked up by passing vessels, others drowned in the cold water, too far from shore, too exhausted to keep swimming. The 743rd Battalion, which landed their tanks directly on the beach from landing craft, lost 8 tanks to German fire, but got the rest ashore intact. Their decision to ignore the launch plan and bring the tanks in close saved dozens of lives and delivered the armor support Omaha Beach desperately needed. On Utah Beach, the story played out differently. The seas were slightly calmer on the western flank, and more importantly, commanders there launched the DD tanks from only 1,000 yards offshore. 28 tanks swam toward shore. 26 made it, arriving wet but functional, providing immediate support to the 4th Infantry Division as they pushed inland. The British and Canadian beaches saw similar success. At Gold, Juno, and Sword, DD tanks launched at reasonable distances in manageable conditions. They suffered casualties. Some tanks sank, some were destroyed by German fire, but overall, the swimming Shermans performed as designed, delivering armor to the beach at a critical moment. The difference between success and disaster came down to distance in sea conditions.
Where commanders launched the tanks close to shore in relatively calm water, Straussler's design worked. Where they launched too far out in rough seas, it failed spectacularly. Nicholas Straussler learns about Omaha Beach through official channels, dry reports that list numbers without context. 27 tanks lost, crew casualties still being tallied. He reads the reports in his workshop, surrounded by blueprints and prototypes for other projects, and feels the weight of those numbers in a way that engineering calculations never prepared him for. He designed the DD tank to save lives, to give assault troops the armor support they needed to survive the beaches. On most of the landing zones, it worked. The tank swam ashore, provided covering fire, and helped break through the beach defenses. Hundreds, maybe thousands of soldiers survived because Sherman tanks were there in the first minutes of the invasion, suppressing bunkers and machine gun nests. But on Omaha Beach, his invention killed the men it was supposed to protect. Not because the design was flawed. The post-battle analysis will confirm that the DD tanks worked exactly as engineered. They failed because they were used beyond their operational limits, launched too far from shore, in seas too rough for the canvas screens to survive. The question that haunts the after-action reviews is simple. Who made the decision to launch at 6,000 yards when conditions made that distance lethal? The answer, like most military disasters, is complicated. The operational plan specified 5,000 yards as the launch distance, but left discretion to individual landing craft commanders. Some chose to launch at the designated distance because those were their orders. Others, seeing the rough conditions, brought their craft closer or aborted the swim entirely. There was no unified command making real-time decisions based on actual conditions. Each LCT skipper made the call alone, and some called it wrong. General Bradley, reviewing the casualties from Omaha Beach, writes in his personal journal that the DD tank losses represent a failure of command judgment, not of equipment. He's right, but that doesn't bring back the men who drowned. The DD tanks continue to serve through the Normandy campaign and beyond. They're used in subsequent amphibious operations, smaller crossings of rivers and canals where the swimming capability proves invaluable. At the Rhine crossing in March 1945, DD tanks swim across under fire, providing immediate armor support on the far bank. No tanks are lost. The conditions are controlled, the distance is short, and commanders have learned the lessons Omaha Beach taught in blood. By the end of the war, the DD tank is recognized as both an innovation and a cautionary tale. The technology worked. The implementation, in at least one critical instance, did not. Straussler continues designing after the war ends. He works on amphibious vehicles, all-terrain transports, specialized military equipment that pushes the boundaries of what's possible. He never quite escapes the shadow of D-Day, both the success and the failure bound together in the same design. He dies in 1966, at 69 years old, his obituaries noting him as the inventor of the DD tank that helped win the war. They mention Normandy, most don't mention the 27 tanks that sank in the Channel and the men who went down with them. The veterans remember, though. Bill Anderson survives the war, comes home to Ohio, and spends the next 40 years trying not to think about the radio calls that cut off mid-transmission, the voices of men he trained with going silent as their tank slipped beneath the waves. He attends reunions of the 741st Tank Battalion, fewer men showing up each year, and every time someone mentions D-Day, he sees that gray water and feels his Shermans sinking before Hayes got them moving along the bottom. In 1984, on the 40th anniversary of D-Day, Anderson returns to Normandy. He stands on Omaha Beach, now peaceful, tourists walking where men died, and he looks out at the water. 6,000 yards offshore is just a distance on a map now. Blue water sparkling in summer sunshine, nothing to mark where 27 tanks rest on the seafloor.
A French journalist approaches him, asks what he's thinking about. Anderson considers the question for a long moment. "I'm thinking about canvas," he says finally, "and how strange it is that something so fragile decided who lived and who died."